A warm welcome to all the participants for this national webinar. And topic is the signature bridge, concept to finish. And I think part one, planning. We have a very eminent engineer, Jose Koreanji. He graduated in civil engineering in 1964 and did his master's from IIT Delhi in structural engineering, and he did postgraduate diploma in earthquake engineering from International Institute of Seismology and Earthquake Engineering, Japan. And he is involved in some of the flagship, pioneering, and significant to Indian infrastructure projects like Jawaharlal Nehru Stadium, ISBT, flyovers, and renovation of fire damaged Vigyan Bhavan. As we all know, Vigyan Bhavan is one of the eminent structures and auditorium which has hosted several conference seminars. Then Parliament Library Building, Madhuban Underpass, a 1.2 kilometer long Janpad Nagar flyover, 2 underpasses in Delhi Outer Ring Road. He offered his services with government, and he is the chief engineer for convincing, planning, designing, and construction management of this signature bridge across river Yamuna in Delhi, which we are going to listen from the master who has convinced the policy makers and also did the planning, both structural and construction planning, and executed it on time within the cost and budget. So he is also chairman on many Bureau of Indian Standard committees on cement and concrete. Cement and concrete are the two essential materials which has replaced traditionally all the conventional materials like brick, stone, timber, wood, then even to a large extent steel also. So he has got a wide experience in concrete technology also. He is a former president of Indian Concrete Institute. Indeed, to my knowledge, I think he is one of the founder members of Indian Concrete Institute also. He has received the Lifetime Award, Achievement Award in 2016, which is very prestigious award in this country, who has contributed to, as I said, to cement, concrete, and durability and sustainability of infrastructure projects in India. He also received the CIDC Vishwakarma Public Officer Award in 2011. Engineer Kurianji has authored over 50 technical papers in spite of his busy schedules of professional commitments in various conferences and published in journals in India and abroad. So friends, I think next 90 minutes, we are going to have a fascination, not a fiction, but a reality of a bridge which has taken shape under his able guidance as an engineer. Now, with this, I leave the platform to the today's speaker. Sir, it's up to you.
Thank you, Reddy Garu. I am extremely happy to see you once more, because we have associated with the Indian Concrete Institute and met on several fora before. And I know that you are now actively participating and taking action to develop the organization further. So it's a great opportunity that you have given, a good platform you have arranged to meet a whole lot of people across the country or to discuss a very interesting project what has been just concluded. And I'm extremely happy to and thankful to you for arranging this one and allowing me to, requesting me to deliver this lecture. So QCrete has been active for quite some time, and they are growing very fast and doing commendable work across in the part of South India. I wish them well also. So thank you, Shelly Fernandez, for introducing me to this circuit. And we had one earlier, and I think one to follow after this. I hope that these deliberations will be useful to the profession. I also welcome all the participants who are, after a day's hard work, available in this evening to listen to me for about an hour's presentation. Later on, we will have few questions and answers. Wherever I can help, I will definitely put in. Rest, we will talk to each other over emails and other communication media. So thank you, all of you, for sparing time to listen to this talk. I will be speaking on a major project done in this country called the Signature Bridge, to concept to finish. So when we discussed the organizers, we thought that we split the whole presentation into two parts. The first part, which is very fascinating, is the planning part of it, because unlike many projects, this has taken time, and we have taken a lot of effort, care to do a planning which will satisfy a whole lot of people. So that part, that saga, that story, I thought that I will tell you in the beginning, along with the design part of it, design and planning part of it. And in the second part, we will come across the actual execution. How did the execution has happened, how the construction project management has taken place, and what are the innovations that has happened in this. There are a whole lot of innovations this used for the first time in this project in this country. So each one of them is fascinating. So I hope I feel that the lecture to follow, that is the construction, will be equally interesting, and for a professional engineer that will be worth listening to you. With that introduction, let me start my presentation on this part. So the agenda for the evening will be, I will just introduce the project, and the whole project is in two parts. One is the tourism destination, still not built, and the second is the bridge, which is already built. And in the design, and the bridge will have several parts continuously going on the planning, design, the concept, the structural system design, and the procurement difficulties that we have faced, and the players who have made this to happen. It was a very interesting thing to work with a team of international leading players in this particular industry. We had people from almost 13 to 14 countries contributing to this one, and it was a very pleasant experience to meet the leaders and work with them to realize this this major project. So I will discuss with those people and the contribution they made towards the end. First, let me introduce you the project. You know the Yamuna River, which is very close to the heart of every Indian, and particularly for Delhi, on which stands on its on bank. Once upon a time, it was on one bank. Now it stands equally spread around both the banks of the Yamuna River. So the mandate given to my organization, which was the Delhi Tourism and Transportation Corporation, was to create a bridge. But when we thought about it, and when we visited the place, and we thought that being a tourism organization, we should be able to do much more things. So with the active participation of the government and the government, as well as my organization, we came up with a dream plan, which is again part of a major plan, which we will discuss some other time. So for that time today, we will discuss the original concept of how to handle this particular project in a place called Wazirabad, which is in the northern part of the Delhi, which is part of the northern the part of the river. So we will just see what it is all about. So this is the basic picture of that particular area which we have taken up. The Wazirabad Wazirabad is a very interesting, historically active place in the northern part of Delhi, and this particular Wazirabad, there is a barrage provided on the north. So this particular barrage is equally important for Delhi because barrage is keeping all the water, drinking water for the Delhi. So this barrage is across the river Yamuna, and the water is held here, and we have got clean water up to this place, and this water is used for Delhi, and it was being used. It is the only source for Delhi for a long time until the Ganga water started flowing into the Delhi. So this is the barrage. This barrage, on the top of barrage, there is a very narrow, hardly two-lane road available, and this particular neck is connecting the entire UP, Bihar, and from the eastern side to the north. That is, we go to Punjab and up to all those places. So this is a very interesting link which connects the east to the north. So a whole lot of traffic, especially the goods traffic, goes through this area. But at the same time, this side, the eastern side, is very thickly populated. So, but most of them find their work on the west side, which is more developed as it stands today. So a whole lot of traffic is also available from east to west in the morning and going back in the evening. So this was also another thing. And there was a horrific accident that has happened years back when a school bus, because of the traffic congestion, it fell into the river and killed kids. Very unfortunate event. In about 17 kids lost their life. So that created an idea that bridge cannot no longer serve this particular place. So there should be a new bridge constructed, because widening a barrage is impossible in the sense it's extremely difficult. So it was a decision was taken that let us have a bridge. So the initial idea was to have a bridge very close to this place, that is very close to the existing barrage, but it has got huge technical challenges to overcome to putting another bridge there. So a decision was taken after a lot of investigation and everything to move this bridge to about 600-meter downstream of this river Yamuna, and produce a bridge there. So this investigation was done, and a decision was taken by the government of Delhi, and then we were asked to execute this project. The Delhi government requested the Delhi tourism to undertake this project. So we started working on it very closely, and while we were doing it, we were told by the government, by the Chief Minister herself, that look, the Commonwealth Games are coming, and we should create something, a very significant structure which will commemorate this particular event, and that should become a landmark for this games as well as for the city, and the city shall be remembered by this structure. So this was a huge mandate given to us at that time. So she was very passionate about this idea. So this was so that made us think much further than creating just a bridge, and we thought of taking it further. So we took the services of some of the eminent brains in this particular field. We got an architect, Ratan Bartley Boy, who is operating from is an urban designer, urban planner, operating from Bombay. And at the same time, we also looked up who are the best brains, best designers in the world, and we could locate the Slice Bergerman in this and company in this from Germany, and we got him here. And with them, a small group was formed, and we started working on them. From the Indian side, we had the eminent T.N. Subbarao, who is an untiring engineer, and he contributed immensely for coordinating the whole thing and creating a very good project report. So that is the thing. The project report had two parts. one decision was this particular area of Wazirabad was not very well developed. So we thought that the area should also be cleaned up, not only just create a bridge, but the surrounding area should be cleaned up, and that should make the beginning of retrieving Yamuna for the people. So this was the thing, because Delhi, the whole people who are living on the east had absolutely no place to breathe. Even though river bed is so wide for almost 4 kilometers, but the whole place is unusable. So that was the problem. So we thought that we should contribute something for the city, along with a bridge which will take care of the traffic. We should also give something back to the people of Delhi. So this was the idea. So the planning started, and we created a project report. Is about 1,000 pages odd thing, and that contained what we can do for this particular area. So the concept was, briefly, so this is the west side, which has got the out ring road is going like this from west, on the west side of the river Yamuna. This goes to Azadpur, and this goes to YSBT. And on the east side, there is something called an eastern ring road, and this is the Kachuri Khas junction. And from there, the river, from there the main traffic comes there, and it used to go from here. So we tried to locate the bridge somewhere around 600 here. And what the unfortunate part of Yamuna is, until the Wazirabad bridge, the water is reasonably clean, and that is the water we drink every day. But the moment we enter Delhi, there are a whole lot of almost 24 to 30 nalas, which brings all the dirty water to the river and makes the choke the river. And it just can't be, it's almost a cesspool. That is the kind of water that we get from here. This is one of the nala which comes here, the Najafgarh nala, which is one of the biggest nalas available here. There are a whole lot of chemical industries behind it, and it brings a whole lot of junk into this river. So similarly, there is several nalas which starts polluting this river from here. Even though there are very interesting, we'll have a look at it, interesting and heritage area. This is a heritage area. Unfortunately, nobody has taken care, and all those muck comes here and make it bad. So we thought that we'll take about a kilometer plus area and create a water body. So this was the idea. And around this water body, we can create recreational as well as evening facilities where people can come and relax. And on this side, we can create a whole lot of sports facilities, all kinds of sports facilities which can be used for people. Almost 1,500 acres of land can be retrieved and create facilities for the common man. So this was the idea. So we divided the project into two parts. Part one is the tourism destination, and part two the significant bridge. So this is what we have done. And what we have done was to create this water body, and this water body can be utilized because Delhi just doesn't have any water body of significance. That is the unfortunate part of it. So we thought that this particular kilometer long water can be utilized for water sports like kayaking. There are many water sports facilities available, and people can come in the evening or during the sports areas. I mean, times you can utilize this water as a theme park. So this was the idea. To create this water body, we have located the technology that of the rubber bridge, the rubber barrage. It is it's already constructed, so thousands of such things are existing in other places. So this is simply a rubber tube which can be pneumatically expanded and reduced. So this was the idea. Air can be pumped into this one. This will come up and it can hold water. The idea was during the flood, the barrage will be, rubber barrage will be collapsed. But during the rain, once the flood is over, this can be air can be pumped into this one, and it can hold water a meter, 2 meters, whatever is requirement, and the barrage can be created. So this was the idea. So during flood, you will close it and that part cannot be utilized at all. This technology was available and we worked out the technology and cost aspect. So we found it is a very interesting things possible. This water body can be utilized for, boating. There are several things that water can be utilized. So this was the idea. The water body will become one of the central attraction for the people of Delhi. In the evenings, it's a sacred area also. There are so many things can happen. People can come in the evening, late evenings, and enjoy. You can have restaurants, floating restaurant. There are many things that can happen here. And this also is a very interestingly very religious place. During Chhat Puja, whole lot of people come here. So we create specialized facilities for them, so that it becomes a regular evenings for people to come to pray and pay respects to their gods. So this was the idea. So these are some of the things which is happening now. People come and feed the birds, and it's a very interesting evening, but you can't approach because of other dirt. But there are people who come and really enjoy their life here. People do come and play. I mean, it's very interesting that occasions you can see a whole lot of people without any publicity come and enjoy themselves in this particular area. This happens very often. And we also got a dhobi ghat there, which is the water has to be supplied to them every day. And practically the entire northern part of Delhi, their clothes are cleaned this particular place. So we'll create facilities for these people also. This is the idea. Then there is a Smashan Ghat, and there are so many activities, cultural activities, heritage activities going in that particular place. And there is also very interesting on the western side, there is a Buddhist colony, Tibetan colony, which brings in the heritage of the Buddhism here. And we thought that we can create a particular kind of places for reviving and showcasing their culture in this particular place. And the eateries in this particular place very famous. In the evening, it is full of university people. We thought that we can bring in more Delhiites to this particular place, and this Tibetan culture will be a major attraction for them. So this is a very interesting. There is they bring a lot of clothes, they bring a lot of interesting food. All of them are very economically priced, so a whole lot of people visit them. We can create amphitheaters, and so that cultural events can be created. And on the eastern side, we thought that we'll create places where evening people can come from East Delhi or from both sides, and we'll create places for which we have divided. After doing the hydraulic study, we have divided this particular area into 2-3 classes. That is inundation floods, 25-year-old flood. Some areas will be every 25 years it will be inundated. Some will be 50 years, some will be 75 years, some will be 100-year flood. So where the 100-year flood is there, we can create more permanent facilities like hockey grounds or football grounds or cricket grounds or golf or anything like that one. Rest of the places you can have basketball courts, volleyball courts, running tracks and everything. And on the frequently flooded areas, we can have temporary structures like walkways and gazebos and eateries and other places where you can come and enjoy the place. So this was the idea, basic idea of creating a tourism centric attraction for a particular place, water sports, any number of them. So we presented the project to the government. So because everybody was busy with preparation for the games, and so they thought that in one of the cabinet meetings they decided that creating cleaning water and getting something done in the river Yamuna is a very sensitive issue, because whole lot of environment people are also involved. So that will take time. So for the time, even though they said it should be done, for the time being, let TDC take up the bridge and let them come back to us with the bridge first, and we will think about the tourism destination area as a second phase. So this was a definitive decision. So we, for the time being, we said we'll keep it for the late future. We'll focus on the bridge. So from there onwards, our idea was to present a proper bridge structure to the government and the people to take a call on this one. So if you look at the whole thing, we have divided the project of the bridge itself into several sub projects. So if you look at the scheme, you will see that um, the on the western side, where this particular road from Kasturi Khas come to the western side and meet the ring road, we need a signal free area, signal free approach with several flyovers or whatever we call grade separators to make the traffic smooth and there is no conflict of anything. In addition, there was a whole lot of cyclists coming from this place, so we were asked to introduce also a smooth and clutter free ride for the cyclist also. So that was the idea. So we created a separate sub project of the western approach. This was one of them. And then similarly on the eastern side also, we were to create a signal free approach for the main traffic comes here. At the same time, the ring road, which is going to develop as a ring road for the east, a clutter free traffic, signal free area. So this is the eastern approach. So this is another sub project. And then the signature bridge. So there are three sub projects in the main project. That is the signature bridge, the western approach, and the eastern approach. This was the scheme that we thought that will make the life easier for us. So if you take the western approach itself, so this is the scheme that we have created, because I will not go into details. It's a very interesting project. The tilted portion alone is about 12.85 lane kilometers, and the Ariwal portion or the embankments is about 1.8 kilometers lane kilometers. The road on grade is about 12 lane kilometers, and there's a cycle track of about 3.5 kilometers in this particular area. And so it's almost like a spaghetti, but then the traffic is absolutely signal free. Maybe some other time we could discuss the traffic pattern, how the geometrics were done, and how the technique was done. It's a very interesting part. A lot of new technologies we have used in this one. The curves are very sharp, but at the same time very safe. So this is what we have done for the western approach. But today my focus will be on the bridge only. Maybe some other time. This is a very interesting project, completely done in very smoothly and using excellent technology. So if you go to the eastern approach, you will see that similarly the tilted portion is less. It is about 4.76 lane kilometers, but there is a 12 lane kilometer long embankment, which is done in concrete. The entire pavement on the surface is done in pavement quality concrete, using completely totally mechanized pavement quality concrete has been done for the entire embankment here. Almost 1.8 kilometers of RE wall and 20 lane kilometers of roads were created for the eastern approach. And it has got very specially, we have got for the eastern approach, the entire foundations were in well. Very interesting project. On the western approach, it is all piles. So all kinds of technologies were used in this particular project. And for the signature bridge, we started thinking about the signature bridge. So we get into the topic of the day, the planning part of this the bridge. So we started thinking about it in any number of almost 10-15 days of clear thinking, that what can be presented as a unique thing to Delhi by the engineering, by doing heavy engineering, at the same time very aesthetically pleasing, and it should become a memorable structure. So this is the idea. This is the idea of the government, and this is the idea of our group also, that we can present the government something. Now this is the most interesting part of it. When such a significant sub word is used, what is significant? This was the idea. So this was an idea which just went up and down before we came to a solution. So this was a very interesting journey. I thought that it will be interesting for people to see how very careful and very fine minds work together to create something which is quite unique for this country. So this story is very interesting part. So I didn't want to skip it. That is why I told the organizers that let us do this presentation in 2 parts so that it's quite interesting. It's not heavily mathematical, it's not highly technical. It is a process of how to bring in aesthetics, and as you will come to know, it is in your mind and in your determination to do good things. So that was created this project. So when we started thinking about the options, there are several options available to do. So one of the emerging technologies at that time for doing bridges were cable stayed bridges. And many of you will know that by the time when we started thinking, India had already cable stayed bridges in Calcutta, and we had one in Naini nearing completion. So this is nothing new for as far as the technology is concerned. But our requirement was that we wanted to create a water body across Yamuna, and we needed a clutter-free area for this water body. So we wanted to make sure that this water body will not have many piers. So invariably the solution came to a cable stay portion, so that the large width is available for a free waterway. So roughly about 250 to 500 meter would be adequate. That is what we thought. So we definitely, after a lot of discussion and choices and decision making, we zeroed in on a cable stayed type of technology for this particular area. So while creating the technology, we thought that we look at we look at the existing tall structures around Delhi, and one of the most attractive and the signature structure of Delhi is Qutub Minar. I hope many of you, most of you would have visited this beautiful structure, and it is also very unique that this is the tallest masonry structure in the world. Many of the people may not aware. As engineers, we should know. This is to our credit, the ancestors have done. This is the tallest masonry. It has not been surpassed by anybody so far. Tallest masonry structure in the world. So this is about 75 meters. So we thought that let us create something double the height. So that will be one of the way to make it unique. So we created a cable pylon which is 160 meter high. So this was the idea. So almost 160 meter high pylon, and with a symmetrical cabling. That means cables on both sides. So this side will be on one side will be 250 meters, this side will be 250 meters, and with a central pylon and just cables. This will make it interesting because of the height will make it quite visible and unique. This is what we thought. To add a little more interest to this one, we created a restaurant on the top, a viewing platform and a restaurant on the top, which can be approached through lifts running on the sides. Through the lifts, you can. This is a arrival platform. Through the road, there will be separate lane for them. Come here, use the lift, and go to the top, and enjoy the panorama of Delhi, both in the daytime as well as in the evening. And you can have a bite. A small restaurant was also planned there. So this was the idea. And if you look at it separately, I mean the design was further developed. So this is the way it will look, because we created an unsymmetrical pylon. There will be 2 pylons at the center. One will be slightly taller than the other. And this was the existing a bridge which was used in the summertime for a temporary bridge on pontoons, which will be used. So on the scenery, the bridge would have looked something like this, without, of course, the tourism destination. So this is the one which we have created, and we were very confident. Sorry. That this will catch the eye of the decision makers. So this we studied further, we developed it, and done a lot of work. And this is the way to look in the daytime. It's quite an interesting and challenging. We thought it's quite challenging, and in the night we can use very good lighting system. And in the night this will look like this one. You can see the top of the viewing platform. With all those things, we thought that this is a very good design according to us, and we will present it to the government. So after a lot of preparations, we went to government to present this one. This is the arrival platform, and we presented it to the government. And there was a meeting. Chief Minister took the meeting. Most of the stakeholders were there, and they went through the presentation very well. And at the end of the presentation, everybody said it's quite interesting and worth pursuing. Then the Chief Minister, Mrs. Sheila Dikshit, raised one very small question. He asked the main designer, Mr. York Kleisch, has any similar bridge been done anywhere in the world? So he can be talked as one of the, if you look at the best 4 bridge firms in the world, Schleichbergerman stands up as one of them. So he said, yes, ma'am, it can be, you can say that there are many structures like this one coming, but this has got its own features which will make it unique. So she asked a question, can you making something which has never been done anywhere in the world? So the gentleman who was standing just sat down, and it took him completely off his balance, and he sat down for a moment and he looked at all of us. And when we discussed among ourselves, we said that this, a lot of work has been done, this one, and this is done. She said, fine. So I'm just asking a question, can you do it? So he said, he stood up again and said, ma'am, it is possible to do, but I need time. So she simply asked a question, how much time will require? He said, I will require minimum 2 weeks time to go through the whole morphs again and come back with a better, a thing which has never been done anywhere. She simply replied, say, Mr. York, you take 1 month, but give me something which is extremely unique. I want something to be left for Delhi, which should be unique and stay forever. So this was the idea. So like us, the whole team accepted the challenge, and we went partly disappointed, partly anxious, and partly with a query, how do we handle it? And then we started working day and night. We, the architect, the engineers, all huddled together, practically sleepless nights, and started thinking about one by one. After quite a bit of time, we thought that waiting for 1 month and getting another rejection would be a problem. So we will make a design and go back again very soon so that we can develop it further. So one of the design which came, and we also wanted to give it an Indian touch. So we thought that let there be a design. So focused on the pylon and created a design something like this, very interesting design. A pylon which splits and then joined on the top with the platform on the top and the cable net, the cable crisscross, and this will make a very interesting spectacle. And to be frank, this such a structure has never been done anywhere before. So we are quite confident that this will go through. And we made studies on this one with day and night presentation. Quite a bit of images were created, a lot of consultations were done, and went back to the government. Lighting, design, everything was done and went back to the government. This is the way it would have looked. And the committee met again and went through the whole thing. They said it's a huge improvement. This is something unique, but few people in that committee felt that this has certain connotations which may not be the right thing to do for Delhi. So let it be, it's a public project, and let there be no way to criticize this particular project, that it represents one or the other at all. So this was a thing, and again the questions raised, the committee raised the issue, can we look at some other design? So this will again take time, but that 1 month will start standing on our back. So we said yes, we'll go back and try something else, and from there on we started working very heavily on other ideas which can come on this one. These were some of the views that we presented to them at that time, but this was not so good. We were not more or less not accepted. We had to come with other design. So the next design was a very interesting thing. It's a long arch of 600 meters span. which is not many parallels for this one. The scheme is something like this. That is a long arch, very long, shallow arch, which at the top there is a viewing platform, and you can walk from all the four sides. Walk, and the slope is so adjusted that people are able to walk, and it should be a hollow shell structure. You can walk, come to the viewing platform, enjoy, and walk down. There's no mechanism required to do this one. So this was an interesting thing in terms of use of the bridge by the people. So you can call it a very simple concept, but very, very interesting and very striking. So that was the idea. But again, the committee said because the arch bridges are nothing new for this world, there are many, many arch bridges existing. So we don't agree with this one. This was the presentation. This is the way it would have looked. Quite interesting, but not acceptable to the committee. So from there once it becomes quite frantic how to handle this particular project. It is almost impossible to get an idea which will go through. So many sketches were done from there onwards, that went to the drawing room, each group 3-4 different groups, and working on possibilities like something like this, sketches, hand sketches, discussing. Each man creates design and then discussing with people. So this went on. This is another one, whether we can have a cable stay as well as cable net. I mean, both the things together, a cable stay and a suspension bridge, partly suspended, partly cable stay. This is another interesting concept which was thought of, but it was not coming through as a challenge or something unique. So another was a thing like Viking design. I mean, some kind of a design with V separated V pylon with cable stays coming on both sides from the top, of course. And this was an interesting design because again it's a star shape on the bottom. Quite an interesting design, but again not found favor because there was no uniqueness or something that could be done. This was again, the design was split into two, almost like a ship with the two pylons at the end and a cable stay which is almost 500 meters. Quite interesting, but again this is they said there's no personality for this bridge, so try something else. Then a simple thing came because there are a lot of hills around that particular place. We'll go a simple Estados bridge. Again the question came whether Estados bridge have been done. Yes, this has been done many places, so we did not take it further at all on this particular design. From there we were, I mean, a design, a solution has to be worked out, and the solution should be worked. So worked on a solution which is interesting. I mean, on the eastern side, it's all it's a kind of forest. So people thought that we can create a pylon which is quite tall, as if it's coming from the forest, and use a suspension bridge. That particular design was with cables was again evoked, and this was presented. When presented, they said it is okay, but a few voices came. It looks like a prehistoric animal without its head. So this was the comment came. So that killed the whole project. Whole design that was shot down, saying that this may not be a good idea. That doesn't look so good. So let us please bring something else. So we found out another solution, almost similar to that one, but change the shape a little. It's again a cable stay bridge with a pylon which is curving towards the side, and the cables are strung there. And these cables it's an unsymmetrical bridge. First time we thought that we'll provide an unsymmetric, that idea came, an unsymmetric bridge, cable stayed bridge, which is not very usual. It's there, but it's not very usual, and with the cables on one side, and the whole force should be pulled back and by these two legs on the rear. So this was a design which was presented. They said it looks good, except that again that some kind of an animal form is coming here. So what to do about this one? Otherwise, the shape was almost interesting. The concept was almost interesting, and the people were prepared to go by I mean, something improved version of this one. So we looked at the problem of the long legs and solved it by bringing it closer, but still it looked like clumsy, little clumsy, even though some portion of it was very good. The leg was creating a problem, so we knocked it off and provided 2 backstays, and it looked good. And this was almost coming to a solution. So the bridge definitely looked very, very interesting, and was attractive to many people, and it was also looked aesthetically good. And the backstays, things have improved. It was not very that frightening, so that animal look has disappeared, and it's almost looked like a structure. So that was the interesting thing, and we went forward and made a major change. This has saved the day. What has happened was, the idea was to reverse the inclination to the backside. So the whole of the pylon was reversed. It's almost like falling down, and it is inclined towards its back, and then the cable stay keeps the bridge there. This is a very interesting concept. In fact, this is the concept finally went through. If you look at the dynamics of this project, the very dynamic, it looks so dynamic, and the dynamics is this, that the concept is the pylon is trying to fall down, and it is being kept by the deck, the weight of the deck, or the other way around, the deck is being held in position by the weight of the pylon. So it is an extremely delicate balance of the 2 structures. One of the best, one of the very, very ingenious structural solution has been worked out. And the idea was, any variation that can come between the weight of the pylon and the deck can be managed by the backstays. So this concept was very, very interesting. It is an excellent structural solution, very, very interesting, but very simple, but at the same time extremely aesthetic. So this design was more or less looking very good, but one question came. Everything is nice, but the 2 cable, the backstays on the 2 backstays on the top, sorry, these backstays which is coming from the top is slightly killing the whole dynamics of this project. The aesthetic is killed by these 2. The question came whether we can remove it. So structurally, it was said yes, it can be relieved, it can be released, but at the cost of the structure. So what happened was, when we removed this one, you can see the way it has definitely improved the whole thing. It looks much more neater, cleaner, very, very nice, extremely nice. But then the problem was, structurally speaking, it's a little disaster. So that is what has happened. The entire this particular portion will be a cantilever. The whole weight of the deck, which is carried up to the top of the pylon, this bending moment at this place will be very, very high. So this was the main issue, but it is doable, except that it becomes costly, it becomes structurally very difficult to design, and the material cost is going to be quite high. And so this was the thing, but they said the design is very, very interesting, and please develop it and come back to us. So when we started working exactly on this one, couple of issues came out. One, the project was being handled with concrete. By the time, there are several other procurement progresses also started. So the structure was being planned in concrete, and to handle that kind of a huge bending moment would have been an impossible thing with concrete there. Number 2 was, this particular curvature is also creating a problem to do a structure in concrete for that height of 175 meters. So this came to the conclusion that we have to think of alternatives of this one. Otherwise, we told that it is possible to do. Then they said, please work on this, come back to us. So we further worked on this one, and we reduced the inclination a little, and then started working seriously on the load paths, on the loads and everything. So we came back with a design which is a folded structure. The advantage of this folded structure was two. One is that it is easy to make. We have not lost the aesthetics. We have got extremely clean lines against the sky, and it is a doable project. The only issue was we will no longer be able to do this in concrete. It has to be done in steel because of the very heavy bending moments involved in this particular thing. So that was the only problem. So this design, everybody appreciated, and they said it's extremely good, very good design, and this kind of approval was given to this particular profile of the bridge. And this also made life easy, that from now onwards at least you can do your work quietly from one corner. So this is what has happened, and we started working on it. Different views and different dimensions were selected. The ultimately idea was that this is a bridge which is in the form of a namaste, which is got an Indian character, as if we put our hands, folded hands, and welcome people from that side. So this is actually a form of a very highly Indian motif of a namaste, using that folded plates was created, and it was doable. Only thing is, has been done in steel, which created a major problem, controversy in it. It created a problem for the team. It's almost jeopardized the project. That is the only issue. We'll come to that later in the lecture. But the scheme was accepted, and we started working on it. So from there, we created a design with a folded plate-like structure, with a viewing platform on the top, which is almost 25-meter high. This particular thing, which can be lighted in the night. This will have about 25 meters and four decks to which people can come. And on the front there will be cables, 16 pairs of cable, and on the back there will be 4 pairs of cable. The concept, as I said earlier, was the weight of the pylon balances the weight of the deck. So it's a fine balance of the two forces, and any unbalance due to live load or other forces will be managed by these backstays. So this concept was very interesting, aesthetically very nice, structurally very interesting, and good to look at, and very efficient also, except the cost. So that was the issue. So, and then it was also decided that how to handle this one if it's in steel. So a whole lot of work was going on the heavy engineering was going on that side. We'll come to that when we reach the construction part of it. Construction part of it will just excuse me. Construction part of it. So this is the way different views were created for presentations at the different places, number of places, because it had to get the approval of the Urban Commission and whole lot of leading architects as well as other people. It was consulted widely among whole lot of people, and so we had make several presentations to many people, and this is the way it would have looked in the night. And from there onwards, we started working on the engineering part of it. Basically, it is 2 plates, simple 2 plates kept on 2 columns, held back, and with the stays coming from the top. So this is the way it is. This is the basic things. So we studied the profile of lot of studies were done. What should be the profile? A number of studies were done and created this particular, finalized the particular dimensions. And this is the way it would have looked. A namaste, huge namaste to hold people. So this design was accepted and the detailed study started. So from the architectural profile, one has to convert this into a structural scheme. So this is what has been done there. On the top is the architectural scheme, which was accepted. And on the bottom, this become a structural thing with spans. Main span is 251 meters and the height goes to 151.4 from the deck level. And on this side, there will be normal span. This will be the 4 sets of backstays. This is the 16 pairs of front cables. So this is the way it is done, and there will be another 72 meters of approach. So the first expansion joint is here, the another one will be here. So total 575 meters of the bridge. So this is the structural system that was put to design. So if you convert them into a simple design, you will see like this one, that the first expansion joint, the stay cables, and a composite deck. Basically it is steel and concrete. Where major innovation has been done here, we'll come to that later. And this 251 meter main span, 16 pairs of cables, and the pylon, we have divided them into doable parts so that it can be fabricated elsewhere and assembled at site. So this was the idea. Backstays cable, 4 of them, and this particular place is a very huge innovation in terms of its foundations as well as the bearings. So this is another innovation. We'll discuss it later in the next lecture. The issue was this particular backstay cable bring a huge uplift to the top. This uplift has to be kept down by a dead man of a from here. A dead weight is required here. Creating a dead weight was an issue, and at the same time, since it is a deck with a bearing here, this is a steel diaphragm bearing, is almost rotating fixed bearing. And to be interestingly, maybe we can discuss in the next one, this is a bearing which is the biggest bearings in the world. This particular bearing, it's a steel bearing. This is at the time, I think still we hold the record. It's the biggest bearings in the world. So this particular place almost cannot move. So but the bridge can move this way and that way. So that movement has to be accommodated, that the bridge can move in temperature or anything. So the bridge should be movable at this particular place. At the same time, it should be able to transfer the tension to the bottom dead man. So this was a very interesting design, for which something called a pendulum bearing has been taken, a huge one, very interesting. Now it's been installed. We'll discuss about it in the next one. So these are some of the interesting thing. And the expansion joint at this particular place is almost 1000 millimeters. So very interesting. Slightly skew expansion joint. That's also another very interesting design that has been done there. So the entire design and fabrication and the innovations are all very, very interesting. We will keep it for the next lecture. So from there, if you look at, we were finalizing the thing. If you look at the deck, sorry, the deck has 36.2 meter is the width of the deck, end to end. It's almost the normal span of a bridge. So that is the interesting thing. And the whole thing is kept with one single steel beam, which is this particular beam. This beam is there. Several such beams are there. This beam is pulled up by cables. From here, 2 cables goes up, and cables come, and that 16 pair of cable lifts the this particular longitudinal beam. This particular longitudinal beam on both sides, and from this beam, these particular beams of steel beams are being done. Several of such things, and of course other connected by cross beams also. So this is the basic deck. On the top of this one, there is concrete. This is again an innovation that has been done here. This deck has been created with a precast concrete deck. So that is a very interesting and innovation that has been done here. The whole concrete was done using precast panels. So the quality was maintained. We saved time also on this one. So this is the basic cross section of the bridge. And of course, studies were done on the pylon. And then the design started. We had to do the wind tunnel because the Indian codes or any other code doesn't give the pressure coefficients for such a structure, because it's a unique structure. The only way was to do a wind tunnel test. So we wanted to do, of course, in India itself, but we went to many places who had the wind tunnel. So either they were busy or time constraints. Finally, we had to go to Germany, and the wind tunnel test was done in Germany, and the entire pressure coefficients and other dynamic parameters were worked out, and a report was given back to the designer. The interesting thing is the complete seismic response analysis of this particular structure was done by the Indian team. I must compliment the Department of Earthquake Engineering, IIT Roorkee, who have done the design. And because this particular place is very unique, because it is an alluvium, a proper site-specific study had to be done. So first they have done it and created spectra, and using that one, they have done a very detailed dynamic analysis, and the report is very, very interesting for anybody who is going to do the research. And the design came from the Roorkee team, and the mode shapes were worked out. They had to accommodate about 100 modes to reach a solution. So the first mode would look something like this one. This is the second mode in the cables. Third mode, again you can see like that there are several modes were there. So finally the analysis was done for the dead load, live load, and other combinations, and along with the wind, which is not very significant except for the cables, and the earthquake design. And finally the design sizes were finalized. The stick model was worked out, and the stick model analysis was done by the designers Schleich, Berkerman and company. And the model was the stick model was analyzed, the 3D analysis done, and the sizes were worked out finally. And these are some of the bending moment diagrams that came out of it. Normal for dead load and pre-stress. There are several combinations were there. Bending moment diagrams, it's very interesting. And this is the pylon when it is active. Moments on the pylon, dead plus pre-stress, and bending moment on the deck. You can see the things, and you can see the cable and how it has been uniform bending moments and shear force we are getting by proper fine-tuning the cables. And this is the deck forces from this analysis, and this has been worked out. And finally the sizes of the stick model sizes were finalized using the stick model method. And from there, the designers, like Bergman and Patna, they went to a 3D analysis, of course, with finite element. This is basically to confirm that what has been done is absolutely correct. And this particular 3D dynamic finite element analysis confirmed that the forces, after several trials, it has been confirmed that designs are manageable. So this is the typical diagram. Suppose there are a whole lot of reports available, interesting to go through. And then from there onwards, all the structural sizes, once the confirmation came, the structural sizes were finalized, and they started working on the methodology of execution. Now one has to find out the methodology of construction so that these pieces can be designed, because the weights are to be managed and the fabrication has to be done. So a whole lot of issues were to be sorted out, but it is very interesting detailed engineering that was done. And this is the way it looks like. The structural drawings were prepared. Each element had to be drawn. Almost 1,000 drawings were prepared to make these things available. So this is a typical cross section of the top of the pylon, and you've seen the bottom of the pylon, 2 legs coming up. This is the top of the pylon, and most of the members were worked out. Of course, initially it took some time, but it was all finalized and the drawings were prepared, and then the fabrication plan was finalized. So this is one of the very interesting thing what has been done. So the body was divided into parts, like starting from the base, 1, 2, 3, 4, like that one. From here, this is the joint, the bend we call it, and from there onwards several parts were done, so that it is possible to fabricate them, bring it here and erect them using a crane. So this was the concept. But in the process, a problem came when you cut the whole pylon into pieces. These joints become a very difficult thing. Not that it's doable. Earlier we could do that, and in a normal bridge it is not an issue because we put cover plates and just bolt them or rivet them, and that was the idea. But the issue is here, this is a very unique bridge. We are building it for aesthetics, so we can't have a huge array of plates and bolts. Practically the entire structure will be, you will see only plates and bolts. So this had to be avoided anyway. So this solution came from an earlier bridge done in Hong Kong, that the vertical loads, which is a huge majority normally transferred through the plates, can be transferred directly from top plate to the bottom plate. The only thing is that the two plates should match, absolutely match, without any, absolutely no imperfections at all. So those parameters were worked out, that it has to be absolutely plain, a millimeter in a meter, so which is extremely difficult to create in a workshop, in a fabrication shop. That was the difficulty. So what was done to avoid those external plates? What is done is the top plate has a foot plate like this one, the bottom plate has a head plate like this one, and then can be bolted inside, and the vertical load should be directly transferred. So only a very little force used for bending moments and other shear, will be available on the top. So that was done purely for aesthetics. The structural system was worked out, but created a problem of extremely getting, because some of these plates are almost 20 to 23 meters long. To create an absolute plane to match, to mate together, is a huge engineering. So that is the construction engineering. So that we will discuss in the next presentation. So well, with no welding is the industry, at the entire site there is no welding allowed, only bolting was permitted. So this has been done, and this is the basic concept, that very little bolting, and most of the structure is transferred through direct contact. So this is the viewing platform. There are 4 platforms. The lift will come up to this place. From there is spiral staircases which can take you to the top. So this is a typical viewing platform. The 2 lifts come, the bottom one through the legs, and from here you go to the top using the spiral staircase. Outside it's all glass, tempered glass is put there, all the glass, so it is, the whole place is visible. So this is the idea, and typical joints and sections were worked out. And this is the pendulum that I have been discussing. That is the pendulum bearing. That is from the top, these 4 pairs of cables come, and this on one side you have a basic plates, and this is the pendulum elements, and this ties will take the whole thing to the bottom. And so with the result, it is possible to sway this way. These pendulum elements will sway one on the other. So the horizontal forces are taken care, horizontal movements are taken care. At the same time, the tension is transferred to the bottom. So this is through wearing. We'll have a look at it in the next things, but it's a very interesting concept. And then the cables, before finalization, the cables had to be tested. So this was done by the EMPA laboratory in Zurich. That is why we had association from a whole lot of people, about 10 to 14 countries across the world. So the testing was done in a very well equipped, one of the best laboratories in the world. So those were tested. Unfortunately, this is the anchor. Unfortunately, even though the cables was coming from one of the most advanced countries of in this world, the first set of cables failed after a lot of testing, because it has to be done for 1 million cycles. After 1 million cycle, they found that the failures were unacceptable as per the codes available. So that given a setback to the project, and they had to find out a different company, and then again source it, get it tested. Fortunately, the second one passed. So this is some of the views of the, it's a very interesting, very fine engineering testing laboratories. So this is the typical thing. It will have vibrations happening, and the cycles, million cycles, it can continue to do it. And this is the typical cable state active support. This is the active support of the cable. And this is another interesting thing that we will be doing, is looking at that this is the main beam, 3 beams going across, and these are the cross beams which are going across. And then these are the panels, the panels, that is the precast elements that we put it, which will be connected to these steel with shear connectors. So this concept was tried by us in another project, but finalized here. So this saved a whole lot of time, because the structure is done and the paneling work can be done parallelly. So this is the way it has been done. So this is a typical panels that has been done. Each one was numbered and each one was specifically taken care of at the casting yard. And we also done a very interesting design motif on the surface of the bridge, Yamuna, and you can see the motif which has been done. Now it has been done, you can have a look at it. The quantum of concrete used is about 45,000 meter cube, and about 4,700 tons of reinforcement. Steel will be of the order of about 15,000 tons of steel was used for the whole project. And the grades is very interesting. We had at the time, many of these grades are not available. The advantages we'll explain later. It is the S355 J2 plus, that is a normalized one, then 355 NL, 460, 355, and a Fe250 of course were used in this project. And one of the major problem that's given a huge setback to this project and put every one of us in peril was when we went for procurement, we went to the market. We went to the market in the time of October 2006, and the tenders were received in February 2007. What has happened was, this was the time when the China was creating the infrastructure for the Olympics, and they were buying steel from all over the world. With the result, what has happened is the price of steel almost doubled. This was the Dow Jones index. It went from 250 to 400 in a span of calling a tender and receiving a tender. This put the entire project in jeopardy because the cost doubled, and nobody will give us an approval to go forward. So when the tenders came, we found that the cost has gone much beyond its original design, basically because of the market mechanism, because we went to tender at the wrong time. So this created a whole problem, and no approval. Nobody was prepared to give the approval for this kind of a situation. This is the western extension, which is again main coming and going into many parts. Interesting during time, and we have done a very interesting lighting that very aesthetically designed, and we'll have 3 systems: the normal bridge lighting, and we will have this lighting on the weekend, and for very important days like the national festivals or the Diwali, we will have festive ambience levels. So this was the original design. Part of it has been executed, and other thing, this is the way in the night it will look, and the lighting elements were done. And one of the most interesting thing which has not been done such elaborate scale in India is the bridge health monitoring system. It is a comprehensive health monitoring system. It will track the health condition of the bridge on a continuous and real-time basis, and the results will be available, analyzed, and results will be available in your hands on a live basis. It provides the basis, a design validation. This was the main thing that we could, the design validation can be done. Safety of the use, because including from the traffic counts it starts, and it takes care of the wind and the precipitation and many things which will be used. This data can be used for maintenance planning and a long-term performance assessment, so that in future you can do it. So a very detailed instrumentation. In fact, this will be very interesting for a lecture, the entire instrumentation scheme itself. Now it has been completed. It will be very interesting to go and look at it, and another lecture can be organized on this alone. It will have wind, temperature, and pressure, and the rain, that the precipitation, this will be there. Then cable forces are measured, vibration, and then the temperature and strains, all those things are done. Then relative humidity, then seismic measurements, displacement measurements, traffic analyzing by video surveillance, and all those things can be done. Then joint displacement, all those elements are done completely automatically using sensors. Such an elaborate system, and all those systems, the data will be going real time to the headquarters and analyzed, and the results will be there, and created triggers that whenever some particular value triggers, it comes on your center or on your mobile phone, so that the monitoring can be done very carefully at all the time. So what parameters were the environment conditions like wind, rain, and other things, the displacement, tilt and distortion geometry, acceleration, loads and cable forces, corrosion, fatigue. And then we have the other mechanical equipments installed are the lifts. On the incline lifts, very interesting lift is another next time, because these lifts have to move inclined in two directions, one way and both way, two ways inclined travel, and a pylon cleaning system, cable stay cleaning system, then cranes and other things for approach safety and other things, then other cleaning systems were to be done. So this is the typical cable cleaning equipments. And I will come to the last part because time is, I got only a few minutes left. So the main bridge design consultants, hats off to them. It's a joint venture among Schleich Bergermann, one of the and partner from Germany, and Construma Consultancy Private Limited. Very capable team. The entire bridge was done by Schleich Bergermann, Jörg Schleich, as well as his son Mike Schleich, my friend. And the Construma part has done the entire foundation design with head by T.N. Subbarao, an eminent engineer. We lost him recently, and that was a good job done by them. Then the entire architectural issues, all the headaches were borne by Ratan Bartley Boy and Associates, right from beginning till the end. He has been with us and contributed immensely for the aesthetics of this project. The proof consultant, we have one of the best, Sistra from France, and one of the world famous bridge engineer, Michel Verloju, who has done the Millau viaduct in one of the best structures in the world, even stands today. And assisting them was from India was Mrs. Standen Consultants Private Limited. The contractors were giving a JV among Gammon India Limited as the lead partner, and Construtora Cidade of Brazil, and Tensechai of Italy. So these were the three people came together as a JV and completed the bridge. And the approaches consultants were, main consultant designers was Standen Consultants, proof consultant was again Construma Consultants, and main contractors were Gammon India Limited. So that concludes my first part of the lecture. I hope you, because I've taken a little more time because it's a fascinating story, I must tell you. So I hope you enjoyed it, and we can discuss it further if time permits and the organizers agree. Thank you very much for listening to me for almost an hour plus, and I leave it to the organizers now. Thank you very much once again.
Yeah, Aishwarya, any questions there? Any participants? Questions?
So, we'll forward, sir. We'll forward the questions.
Okay.
And, yeah.
So we will conclude. We'll put the vote of thanks. Okay.
Yes.
Yeah. Good evening, friends. We have come to the end of the another interesting topic on an iconic structure, signature bridge. The concept to finish, part 1, planning. Jose Kurian was from the start to finish of this project. Today, he has covered the first part, planning. Mr. Jose Kurian with his today's talk has shown how planning plays a very important role in the entire construction of a bridge, a beautiful iconic structure actually. So his talk is very lively and vibrant and kept the audience glued to the webinar. Thank you, sir. Thank you for your excellent and experience sharing.
Thank you.
We are looking forward for the second part, construction of signature bridge. I thank all the participants who had spared valuable time to attend our QCrete webinar series. I'm Shelly Fernandez signing off till next Monday. We join you all for the second part of webinar. Thank you very much. Thank you.
Thank you.
Thank you.
Come back on the video.
Yes, sir. Yes.
Hello, Shelly.
Yes, yes, sir. Yeah.
It's you closed it?
No, not close, not close. Yeah, tell me, sir.
Okay. No, nothing. I just wanted to know.
Yeah. And we will close it, and next Monday we'll meet again, sir. We'll meet again.
No,
same
Monday.
time.
No. Give me some time because